Today we are discussing theorem 6.1 from the triangle chapter. This is also known as BPT theorem, basic proportionality theorem. If not, this is the theorem invented by the Thales mathematician. On the name of same mathematician, we can call it as a Thales theorem also. So let us see this. What is BPT theorem? What is basic proportionality theorem? If a line is drawn parallel to one side of a triangle to intersect other two sides in the distinct points, the other two sides divides in the same ratio. So what is this Thales theorem? What is this BPT theorem states? Take a triangle. If you draw the parallel line to the third side, definitely it intersects other two sides at a distinct points. Not only intersect distinct points, this parallel line will divide the other two sides in the same ratio. This is very important point what we have here. I will show it on the figure. So when PQ is parallel to YZ, when PQ is parallel to YZ, if PQ is parallel to YZ, then so when we draw the parallel line, what happens? It divides in the same ratio. It divides in the same ratio. So then XP by PY, XP by PY is equal to XQ by QZ. So this is about the basic proportionality theorem in very short. If PQ is parallel to YZ in a triangle XYZ, then XP by PY is equal to XQ by QZ. This is the basic proportionality theorem. So let us prove this theorem. Same thing here. When PQ is parallel to YZ, XP by PY is equal to XQ by QZ. So that is the basic proportionality theorem. After discussion of BPT theorem statement, we'll try to write what he has given in the statement and what we have to prove it. So clearly he has mentioned about the triangle. In triangle ABC, if DE is parallel to BC, so this is he has given. DE is parallel to BC has given. In a triangle ABC, DE is parallel to BC. This is he has given. What we have to require to prove? We have to prove that this D and E intercepts will divide other two sides in the same ratio. That means AD by DB is equal to AE by EC. So same thing I am writing here. That line segment divides other two sides in the same ratio. AD by DB is equal to AE by EC. So that is we have to require to prove this one. So to prove this theorem, we require some construction. With the help of construction, we will prove this theorem. So what we'll do in the construction? We'll join BE. We join BE. As well as we join CD also. CD also we join. So join BE as well as CD. So this is joining. Not only we are joining these two line segments BE and CD, we are drawing the altitude. So how to draw the altitude for different triangles? That I will explain later. We can include in the construction that part. So let us see this. What is important observation to prove this one? So clearly I have shown here two triangles. Look at this blue triangle. Look at this red triangle. So this is having a two qualities here. This is their two triangles have on the same base. This is ABC triangle, that is ABD triangle with the same base. We have same base. Not only same base they are sharing. These two triangles, it is in between two parallel lines. So in between two parallel lines. One is CD. I have shown it as in dotted lines. CD is a line as well as AB is another line. It is in between two parallel lines. So that it is sharing two qualities, that is same base as well as between two parallel sides. Therefore, the area of triangle ABC is same as area of triangle ABD triangle. So why it is so? Why it is so? In 9th class you have learned this theorem. If two triangles on the same base and between same parallel lines are equal in area, so are equal in area, that is the proof already you have learned in the 9th class. Here also I will give the small hint whether the areas are equal or not. So why these two triangles area is equal? It's a simple concept. We can use of half into base into height. Based on that, we can prove that these two areas are equal. These two triangles areas are equal. Let us see how we'll proving this one. So I will drop the perpendicular from C on AB. I will drop the perpendicular from D on AB. I am noting it as CX and DY. Now you tell me, is CX and DY is equal or not? So definitely it is equal. Why? Because of it is in between two parallel lines. What is the definition of parallel lines? The parallel lines, they have same distance at every point. So from C to X, from D to Y, it is having same distance. So the altitudes are same here. CX and DY is same here. So if I and sharing the same base again. So if I write area of ABC triangle, half into base is AB into height is CX, and for this triangle half into base AB into height dy. So definitely half AB already it is equal. Just now you have observed that CX and dy it is equal. Why? Because of it is the distance between two parallel lines, it's same at it everywhere. CX and dy it is equal. So that's why these areas are equal. Area of ABC is equal to area of ABD. So that is very, very important point we will use in this theorem while we are proving. Let us see the second observation, and very, very important observation, how to draw the altitudes for the triangle. This is a concept we have learned in the previous classes, 7th, 8th, 9th classes. Once again, I will revise. Why? Because of this is very, very important role it while we are proving the BPT theorem. So what is altitude of a triangle? The altitude of a triangle is a line segment from the vertex that is perpendicular to the opposite side. So clearly here it is, I have shown ABC triangle. This is acute angle triangle. Acute angle triangle. So here also I have shown one more triangle, that is obtuse angle triangle. So this is obtuse angle triangle. So when you are drawing the altitude for acute angle, the altitude is inside of here. When you draw the same altitude for obtuse angle triangle, it is outside. So ABC is a obtuse angle triangle. First, let we extend AC AC. After that, we have to draw from vertex B to an AC. From vertex B to AC, if I draw, the BD is the altitude here. This is outside. So these are the two very, very important observations you have to note it. When we draw the altitude for acute angle triangle, that is inside of the figure. For obtuse angle triangle, it is outside of the figure. Now, how to calculate the area for both the triangles? For this triangle, half into base. Base I am taking it as AC, and height. For AC, what is a perpendicular? Corresponding perpendicular. Corresponding height I am taking. So that is BD. So this is the way we will calculate area of the triangle for this triangle. For this triangle, half into AC into BD. Let us discuss about this triangle, this upper triangle. I can name it as triangle ADE or triangle AED. I have changed the name of the triangle, but the two triangles represent same triangles. These are represent the same triangles. ADE triangle, AED triangle. Therefore, area of triangle ADE is equal to area of triangle AED. So why it is so? Why? Because of it represents same triangles actually. I have changed the name triangle as well as blue triangle. If you clearly observe, they are sharing the same base. DE is the same base for both the triangles. You look at from this side. You look at from this, your eye should be on the top of DE. So DE is a base. Here also DE is the base for both the triangles. So DEB is a triangle. Here DEC is one more triangle. So both the triangles, they are sharing the same base, and between two parallel lines. In between DE and BC, we have this triangle. This is the triangle also in between DE and BC. So this areas also will equal, because of just now we have discussed an important observation. Between two parallel lines with the same base of two triangles have equal area. So that I can declare area of triangle EDB is equal to area of triangle DEC. So these two areas are equal. These two triangles areas are equal. Since the reason is triangles between two parallel lines with the same base. By this reason, we can conclude that area of triangle EDB is equal to area of triangle DEC. Here, triangle ADE or triangle AED, both are the same triangles. It represents same triangles. Therefore, I have taken it as area of ADE is equal to area of triangle AED triangle. So in the previous discussions, we got that area of BDE triangle and area of DEC triangle have equal area, since with the same base between two parallel lines, and area of triangle ADE and AED have same area because of it represents same triangle. So this discussion, it is we have done the last in the discussion. Now let us draw the altitudes for the triangles. I will draw the altitude for the triangle now. First, I will draw the altitude for EDB triangle. EDB triangle, I am drawing the altitude. So definitely it is altitude is outside of the figure. Why? Because of here D is a obtuse angle triangle. The altitude is here. I'm drawing from E. I am drawing from E. This is altitude. This is altitude. That is EF. For triangle EDP, EF is the altitude. Similarly, we will take another triangle. This is another triangle. DEC triangle. We will draw the altitude for this triangle. From D I am drawing on AC. This is altitude for this triangle. I am naming it as DZ. So in this discussion, just we have drawn the two altitudes for two triangles. One is EDB triangle, one is DEC triangle. I have drawn EF as an altitude, DZ as an altitude for these two triangles. Already we know that area of triangle ADE is equal to area of triangle AED. These are equal in area. Next, area of triangle EDB is equal to area of triangle DEC. So this is also equal. We already discussed this one. You can write the reason here. This represents the same triangles. This is in between two parallel lines with the same base. We can give the reasons here. Now, what is the situation we got it as? A is equal to A, as well as we got it as B is equal to C. So these are the two situations we got it here. A is equal to A and B is equal to C. Now, if I take A is equal to A, both sides if I divide with B, so I am multiplying with 1 by B with A. Here also I am multiplying with 1 by B with A. So definitely it is same. So I can write this as A by B, that is equal to A by, instead of B, what is the value of B here? It is C. So I can write it as C. A by B is equal to A by C. This ratios also will equal. First equation by second equation I can divide. Area of triangle ADE by area of triangle EDB is same as area of triangle AED by area of triangle DEC. So definitely these ratios will be equal. So what I got this as a third equation. From 1 and 2 I got this one. Next. Now I will calculate for each triangle the areas. I am considering ADU triangle here. ADU triangle. In this ADU triangle, what are the altitudes? EF is one altitude. And DZ is also one more altitude. This is one altitude, this is one altitude. So now I will calculate the area of this two triangle. So what is area of ADE triangle? So I can take it as half into base. If I consider AD as the base, the corresponding altitude is EF. So that is about the numerator. We'll discuss the denominator later. So here also same triangles we have ADE triangle, AED triangle, it is same. For this triangle AED, if I consider the base as AE is the base. What is the corresponding altitude here? So definitely DZ is the corresponding altitude here. So I have taken this area and this area. Now I will calculate this area and this area. So same we can calculate it as half into base into height. Here also half into base into height we can calculate. Now, EDB triangle. If you look at where is EDB triangle, EDB triangle. In this EDB triangle, we have drawn the altitude as EF. So if I take BD as the base, DB as the base for this triangle, DB as the base, height is EF. Next, right side denominator. In triangle DEC triangle, where is DEC triangle? DEC triangle, this is DEC triangle. For this DEC triangle, what is the altitude here? DZ is the altitude. I am taking the base as EC. EC as the base and altitude is DZ. DZ. So clearly this ratio is equal to this ratio. If you keenly observe, I can cancel off and off, as well as EF and EF I can cancel here. We can cancel this off and off, as well as DZ and DZ also we can cancel here. So what we got ultimately? Ultimately we got it as AD by DB. AD by DB is equal to AE by EC. AE by EC we got it. So this is only we have to require to prove in this theorem. Ultimately we got it as AD by DB is equal to AE by EC. So that is about the proof.